area under the standard normal curve between z equals negative 1.02 and positive 0.06. What do we do?
Find the z-score. That's -0.06 and add -1.12.
Those are the z-scores. So we look up the probabilities, and then what do we do with those? Subtract them. You always have to put the bigger one first. So we look when the z is 0.06, our probability is 0.5239. When my z is negative 1.02, the probability is 15. And if you subtract those, you get questions. Right there.
Sorry.
Okay.
I think I wasn't feeling my lower back. You did. What?
Let's look at this.
No,
The number of chocolate chips in an 18-ounce bag of Chips Ahoy is approximately normally distributed with a mean of 1,262 and standard deviation 118. Is the 18-ounce necessary here? No, just extra information. So we've got our mean, standard deviation. What's the probability the bag contains between 1,000 and 1,400 chips? So we want the probability the number of chips is between 1,000 and 1,400. What do? Z-scores for each of them. So for the 1,000, x minus the mean divided by standard deviation. So we get -2.22. The other one, R value minus the mean divided by standard deviation. And we get 1.17. So now we have the z's, it's between, so we look up both and subtract them. The 1.17 would have to come first. 0.8790 minus negative 2.22, 2.0132, and we subtract to get our final answer. Is that okay? So if I want to know what proportion has more than 1,200 chips, what am I finding? Probably x is greater than 1,200. So we need our z minus the mean divided by standard deviation. So that's probably z is greater than negative 0.53. How do we do greater than? 1 minus negative 0.53 is 0.2981. And we get 0.701. questions on? Okay. Next problem. The shape of the distribution of the time spent at a drive-through is unknown. However, records indicate the mean is 59.3 seconds and the standard deviation is 13.1 seconds. To assume a normal model, what sample size would be required? It has to be greater than or equal to 30. B. What's the probability that a random sample of 40 cars results in a sample mean? When I say sample mean, what am I talking about? The mean of the sample. What's the notation for that?
Oh, thanks.
This is the X bar, the sample mean. So I'm not just saying that, my value is a certain number. So the previous ones, I wasn't talking about a mean. I was just saying in my one bag, it contained between this number. Here I'm saying, okay, well, we took 40 cars, and I want the mean to be 56.8 seconds or less. So less than or equal to 56.8. Okay, so with these, the one thing that you really need to make sure you know is your criteria. Remember, if we're talking about X bar and P hat, they both have criteria. This one, either the data has to be normal or, like we said in part A, N had to be greater than 30. So my N was bigger than 30, so we can assume it's normal. We're good there. The mean of the X bars, this is on your formula sheet. The mean of the sample means is what? 59.3. Standard deviation of the sample means. Our normal standard deviation divided by the square root of n. That's just straight from the formula sheet. So if I do that, we get 0.0713. Remember, because this variable, when I talk about sample means, I'm talking about X bar, so you need the mean and standard deviation for X bar to turn it into a Z. So we are finding our Z, our value, minus the mean, divided by standard deviation. So we need to find the probability that Z is less than negative 1.21. How do we do less than? Just the number from the table, so negative 1.21 is 0.1131. Is that okay? Last slide. So we've kind of looked at, we've covered essentially 4 sections. The first section was just our plain Z stuff, which is reading the table. That was our first slide. Second slide we had, when I had your X, we just had to turn it into a Z and go from there. The next thing we did when we were talking about our sample means. The final thing, we are talking about the population proportion. So we have a simple random sample of size 300 from a population of 25,000, and the population proportion is P equals 0.7. Describe the sampling distribution. So that's your criteria, your mean, and your standard deviation. Remember, the P hats have 2 criteria. My sample has to be less than 5% of the total population. Is 300 less than 5% of 25,000? 0.05 times your 25,000 gives you 1,250, so we're good there. Second criteria is that n times p times 1 minus p greater than or equal to 10. So the criteria might be the one thing you really should look over and know before your quiz. That's not on the formula sheet. So my n is 300 times 0.7 times 1 minus 0.7. And we get 63, so that's bigger than 10. We're good. How do you find the mean for p hats? Just our p. Standard deviation is what? So we get 0.0265. So, part B. What's the probability of obtaining x equals 198 or more with the characteristic? We're talking about the proportions, so we need a p hat here. How do you get p hat? So 198 over 300. That's on your formula sheet. And we get 0.66. So we want the probability that p hat is greater than or equal to 0.66. So what do? So z is our value minus the mean divided by standard deviation. Negative 1.51. So greater than, we do 1 minus. Negative 1.51 is 0.0655. And that gives us 0.9345. So that's kind of your whirlwind review of all the things. Strongly recommend, look over the criteria for X bar and P hat. That's really the one thing that you have to memorize. The rest of it, the Z's, mean, standard deviation, it's all on your formula sheet. So you have the rest of the day to work on the Chapter 8 packet. That's due tomorrow. Some of you want to take your quiz early because you're going to be gone tomorrow, so you can do that at any time if you would like, or take it first hour tomorrow.